Good morning, good afternoon, or good evening, depending on where you are in the world. I'd like to present to you Lesson 14 of Basic Electronics. And before I start the lesson, I would like to point out to you that if you haven't seen the first 13 lessons, I recommend you watch those first, because that will give you a basis for what we're learning in Basic Electronics, as it is foundational and fundamental to the subject itself. Now, let's start with the topic of basic electronics. Specifically, in this lesson, we're going to talk about LEDs and displays. LED stands for liquid energy, liquid energy display. Oh, sorry, light energy display. Sorry, something LCD, liquid crystal display. Light energy display and displays itself. Now, LEDs can be used for both illumination and as indicators. They can be arranged as 7-segment displays, or as teeny pixels on an OLED that is an organic LED display. What we're going to do in this lesson, I'm going to just say this lesson, not this chapter, but this lesson contains, actually, I'm not even going to talk about recipes, actually. Let me just take that away for now. So just contains topics relating to powering. I'll do a little bit of editing here. Powering, controlling LEDs, as well as use for displays, using a display for Arduino or Raspberry Pi. So to wire up your LED to a GPIO, as general purpose input-output pin to select the value for a series resistor. So the GPIO is usually going out from the IC to whatever it is, okay, or whatever it is, the main chip to a breadboard or another IC. Okay, so that's your GPIO. So you take the pin. That pin itself is regulating the voltage, and that pin going in is going through a resistance. So you can see GPIO pin going to resistance 1, which will regulate the amount of voltage that goes through. And from there, what happens is it's a one-way flow that the diode has that will power up the LED and then eventually go directly to ground. So that's when you connect the LED to a GPIO pin. Now in practice, nearly all LEDs will illuminate to some degree, even with the 3.3 voltage 1 kilo ohm resistor limiting the current. Okay, so this would be limiting the current and the voltage together, because current is the force of pushing electrons, which is the different, and the electrons, and in this case the voltage, which would be the potential difference between the polarity of plus and the minus. So this would be limiting the force of the resistance would be limiting the current flow. So as an even broader rule of thumb, if you don't care about optimizing the brightness of your LED, then the 270 ohm resistor is fine. Just as a reminder, ohm is the name of the it's another name for the power, or power standard name for an electronics for that would be resistance, otherwise known as ohms. It's a unit of basically resistance called ohms. And here in front of us we have this actual main board. This is the Raspberry Squid RGB LED. Notice we have 2 plastic leads, one going into one going to ground and one going to the other part of the board. Okay, so one's going in and the other one's going out. Now this has series resistors for red, green, and blue. That's RGB. red, green, blue. LEDs built to the leads, which is at the end. So these are the leads going, this is the leads going into the board, and the other one is powering the actual LED here at the end. So yes, LEDs are built into the leads, which is on the other end. So you can plug it straight into the GPIO connector of a Raspberry Pi. So specifically here is the plastic lead, and the other end is where the LED is. Now, if we look more specifically, we'll find that it has this flat edge going out, and we have our polarities plus and minus. In this case, it's the anode and the cathode. And with it, it's a 5mm through hole LED. Now, some things to remember is that to drive high power LEDs, you want to power 2.5 watt. That's referring to power. 2.5 watt LED using constant current, and you should be able to control the LED's brightness from PWM GPIO signal on Arduino or Raspberry Pi. So depending on what you're using, it's either Arduino or Raspberry Pi. So if you look at the diagram here, what we're trying to describe is a constant current LED that controls from Arduino or Raspberry Pi. What we simply have is direct current or DC input. This is the voltage going in to the IC. IC's code is LM317, blah, blah, blah. So what we have is, on one end, going in is the DC input that's in, and going out, we have resistance 2. On the other hand, we have, for the other pin, so we have one pin going in the other end, we have resistance 1. This is 470 ohms going in. Okay, we have Q1, and then that will go to resistance 3. That will be your output going out. From resistance 1, on the other side will be going to ground to end the circuit. That way we don't fry that, and we finish the circuit and make sure it's only going in one direction and not overloading what we're doing in the circuit itself. Now, let's move on to talk about, so when GPIO pin is low, Q1 will be off. So you have off and on. This is a switch here. So Q1 will be off and effectively takes part in the circuit. The LM317, which is this IC right here, we have in and out. Okay, so it'll take part in the circuit. LM317 acts as a constant current source, where R2 is the current itself. Okay, so we have current going in, the resistance in at the switch, and the other one is the voltage out, that's resistance 2. Now from the adjustable, we have resistance 3, which is in 470 ohms. Okay. Now one thing to remember is that where R2 sets the current according to the formula, so R2 is the outgoing, so that will determine the current. So current equals 1.2 divided by resistance 2. What's resistance 2? Resistance 2 has to do with the voltage going out. That's going out of the chip back into the circuit. Okay. This whole thing technically is one circuit because it's one larger path. Now the LM317 will get hot if DC input voltage is significantly higher than the forward voltage. That would be voltage in of the LED. In fact, the power it will turn into heat will be, and this formula, this is a general formula. So capital P, there's lowercase p and capital P. So we have capital P's, and by the way, most of these are capitals by default. So capital P equals capital I, so power equals current, subscript F in terms of voltage in. So technically what happens is you have to calculate, algebraically you would need to calculate voltage in minus voltage as a force minus 1.2. You calculate all that, then you multiply the current in terms of the force by it, then you'll get to power. This is just simply Algebra 101, order of operations. So parentheses is always the first thing in the calculation. So in this case, it may not matter. You may come up with the same answer. But in terms of form, always calculate in terms of parentheses first. Now, if the forward voltage of the LED, this is voltage in, as I showed you in the schematic, this is the input voltage, as I said, and voltage F is the forward voltage. That would be F, forward voltage. And then also you have the current, the forward current as well, which is IF. And that is capital I, lowercase f. That's I subscript F. R2 will generally be a low level resistor that will produce heat with the power of power equals 1.2 times current forward. Now when we look at this, we see we have our Arduino Uno main board. Then from there you have your connections to what's called a breadboard, which you've been talking about previously. That's why I mentioned make sure you've seen the previous videos. What we're actually achieving is controlling a constant current source from Arduino. Why? It's going through a circuit. Okay. Now, let's talk some more particulars about this now. We have something called the multiplex signal for 7-segment displays. This, if you look at this in the bottom, that's a 4-digit LED display from Arduino. But let's look more about the 7-segment displays in terms of, or in the context of this LED display. Now, when you talk about multiplexing, you want to talk about a technique that reduces the number of GPIO pins needed to light lots of LEDs. That's multiplexing. Remember that each digit of the display has 7 segments of a figure 8 arrangement, which is each one of these LEDs. Each of these segments are labeled A to G and is connected inside the LED package to all the segments and the same name. In the display, all the cathodes of the segments for a particular digit are connected together as a common cathode. Okay, remember we have plus and we have minus. We have cathode plus, anoid, which is minus. So in this display, all the cathodes of the segment for a particular digit are connected in terms of a common cathode. The LED display has a pin for each one of these 4 common cathodes so that the software can enable, actually I should have separated that, each digit in turn, set its segment pattern, then move on to the next digit. So we do this one after the other. Okay, so if I can make this, I don't know if I can make this bigger. Notice as we're coming in, we're doing this in digits, okay? So we have all the 4 digits, and we do this in terms of bits coming in. So we have our main IC, which is Arduino Uno, and we have displays here, other functionalities, and then we have ground 1 and 2, and then of course a reserve pin we're doing the last one. What we're seeing actually is as it's going in, as in from pin the pin 1 going out, that'd be Q1. The second one is Q2, Q3, Q4. Notice with each one, what you're having is it's going out forward voltage. It's going to be met with a certain force of resistance, which is R1 at 1000. Each one is consistent with 1000 after the other. After resistance, it's going to ground. The next thing we notice is that we have A through G going through a circuit that has a resistance and then going directly into the pin that's Arduino. Okay, so that's what we're seeing. In this example, we have a 7-segment display on the breadboard. What we're having is the Arduino board itself connected to the breadboard that outputs an LED display. So to talk more about this in terms of multiplexing a 7-segment display on a breadboard, we have to consider controlling many LEDs. So here we have the output LEDs, 1, 2, 3, 4, technically for each digit. Now I use a technique called Charlie plexing. Technique takes advantage of the feature of GPIO pins, that's general purpose input-output pins, that allows them to be changed from outputs to inputs while the program is running. Now, the program itself, which I won't go into the programming of it, the configuration so much, but this can regulate or customize how this is working in terms of its settings. Now, when a pin is changed to be an input, not enough current will flow through it to light an LED or influence other pins connected to LED that are set as outputs. What we have here is we have a series of 3 resistors. Now that's denoted as A, B, and C. A will have 150 ohms of resistance going to LED 1. Notice we have endpoints here. And for B, we all have a resistance of 150. Each, of course, A, B, and C both, as it comes in for each resistor, it's 150 resistance for ohms. And then that second one, B, will go to LED 2. Notice that the current flow is going out. For C, we have the same power of resistance, which is 150 ohms, going to LED 3 and LED 4. Now, with 5 and 6, both LED 2 and LED 4 are pointing away, and now at resistance 2, we go with LED 2. LED 2 will go to LED. You notice that this resistance will be going to LED 5 and LED 6. And simply what you saw was the Charlie plexing 6 LEDs. Here is a practical example of application on the breadboard. These are the actual connections where you can test out your connections between the IC, the main board ICs, and any other applications they're in. What you're going to see is the number of LEDs that can be controlled by the number of GPIOs. That's your general purpose input-output pins, denoted as N, which is any number used in is given by the formula. That's the LEDs. So we're trying to find the number in LEDs equals N, which is any number, squared minus N. Okay, so for example, suppose let's say N equals 10. It's basic algebra. N equals 10, we put N, so we have N equals 10, therefore 10 times 10 is 100. And then you minus 10, it would give you 90. We have to define what N is equal to, and then we can solve the algebraic formula. Next thing we want to consider is when we change the colors of RGB LEDs. In order to do that, we want to wire up a common cathode. Remember, this is positive charge. Cathode RGB LED. In order to do that, when we look at the wiring, we have to consider all 3 resistances in terms of red, green, and blue in that order. So for red, GPIO red, we have resistance 1, which has the resistance power of 270 ohms. For resistance 2, which is the GPIO green, has resistance 2 of 150 ohms. And GPI blue has a resistance 3 of 100 resistance of ohms of resistance, which is almost redundant here. So when we look at our red, green, blue, general purpose input output, you notice that the red resistance is going to go to the red diode. That's going to direct the current flow. For the second resistor, that's going to go to a green diode, which is also going to direct the current flow. Now notice it's all going towards ground. And for the third one, it's going to go through GPI blue general purpose input output blue goes to resistance 3, which is has 100 ohms for resistance force. And then that will go directly from GPI blue to the resistor, to the diode blue. Okay, so the idea is we come in for each color-coded red, green, blue, they all have their respective resistance force going directly to their respective diode, meaning GPI red goes to diode red, GPI green goes to diode green, and GPIO blue goes to diode blue. All three of them are going in a direction because that's what a diode does, is it forces the direction of the current flow going to ground. Now, if we look at this from an example standpoint, this is our red RGB LED pins. That's red, green, blue. We notice that we have our leads going out and our leads going in. It's two ends to the leads. So what we have red is one lead. Second one, we have a common. Third is the green, and fourth is the blue. Now, as that is one example of how that's going to work from an example standpoint of the schematic that we just looked at, very basic. Now let's look at the LED display. Okay, so this is a 12C segment LED, 7-segment LED display. Notice we've got 4 digits here for output. So let's look at a basic idea. Now, when we connect to the 12C display in Arduino or Raspberry Pi, where we're going to be looking in for RC is, for the IC is the voltage going in, which is 5 volts. And then we're going to look at GPIO2, which goes to the SDA. And then that parted chip goes to the I2C display. It'll go basically to the display. Then we have the GPIO3, which is the SCL GPIO3 going to SCL. So that the GPIO lead goes into the IC. And finally, we have a ground lead that goes directly to ground. Now, remember it's for Arduino or Raspberry Pi. The connections between Raspberry Pi and the module are as follows. VCC, which is a positive, which is a cathode, is a display of 5 volts on Raspberry Pi GPIO connector. Then we have ground, which is negative on the display of ground on the Raspberry Pi GPIO connector, which you just saw here, which is GND standing for ground. That's the ground lead going out to ground. Then we have SDA-D, that should refer to diode, D for diode, on the display of GPIO2 SDA. So SDA would refer to the diode, which would control the flow of the current. On the Raspberry Pi GPIO connector. SCL, that's C, would refer to the capacitor. On the display GPIO3 SCL, so when you see SCL, you know that's referring to the capacitor, and that will remember that a capacitor's core function is to store charge. Okay, that's particularly important when we have excess amount of voltage or when we have resistors in parallel. So remember that VCC is abbreviation for volts collector. I know that sounds redundant, but that's what it is. It's frequently used to identify the positive power supply pin of an IC or module. Remember that for display graphics or text on LED displays that you need to use a 12C, that's 12 capacitor, OLED display like the one shown above the Arduino, which is in this case here. What we have is actual photo of a 12C OLED display attached to Arduino, which is this part here where it says Electronics Cookbook. That's the display. That's connected to a plastic lead that's going out. Right? So the board is connected into the display. Okay. So you have one that's going into the leads. So you have pins that's going to regulate the voltage, and the other one is going to regulate uh, the peripheral for the output display. So you have one plastic lead going in for voltage and the other one going for the display itself. So the HD44780 can be configured with either a 4 or 8-bit parallel data bus, which is what you see here. The 4-bit data bus is used only on bits 4 to 7 of the bus that are used. Now the pin V0 is used to control the contrast of the screen. Okay, so each part has its own function. Okay, and you'll need to adjust R1 to be able to see anything on the screen. Furthermore, when you look at the next example here, we also see an Arduino Uno, and you notice it's connected through the breadboard, and the breadboard is with the display is connected to the breadboard itself, and that is an HD44780 16 by 12 LCD display connected to an Arduino. Now, to give more particulars, when we look at the wiring, this is the actual electrical wire to the breadboard. We need to look at the display here, which is on top of the actual circuit board, which is in green, and that's going to go to that's connected to the breadboard, which is connected to the Arduino Uno bread, which of course also is connected to the breadboard. To look at this more in terms of from its schematic, what we're seeing is 5 volts going in. Okay, we have different general purpose input output. 27 and 22. 27 goes to RS, 22 goes to EN, and the R-W goes to ground. Also, we have to consider our diodes. That's for GPI 25 goes to diode 4, GPI 24 goes to diode 5, GPL 23 goes to diode 6, and GPL 18 goes to diode 7. Remember that the purpose on one of the leads going out is the LED plus. Now this chip itself is going to connect to our display. So we have a display logic here. We have the electrical endpoint going out to the display. Then we have the logic that's controlling that. Now from the LED out, we're going to have our first resistance power of 10K, which is 10,000 ohms. Also, we have another one, so we have plus and minus for polarities, both going out, which will indicate what is how much current. So the difference between the plus and the minus has to do with the potential, which would be our voltage, and then the amount to limit our current flow in terms of voltage would be through a resistance or resistor. And from there, it's going out to power it's going also out through the LED endpoint and then finally going to the ground. Because we got a ground pin going out, it goes out through that endpoint and then goes out to ground. Okay. And I think that will end it for now, yes. There's actually programming that you can set. There's instructions where you can set certain settings of your Arduino or for your Raspberry Pi. Those things will set the voltages or other functionalities that can be looked at separately, but the main part is the core of the electronics itself of how this actually works. Okay, so I think that will do it for this lesson. So remember something, we were talking about LEDs and their display. We have to understand red, green, blue are display, the resistors in parallel, the current flow in which direction directed by the diode, its application, and experimenting on, being able to test it out on breadboards before we actually connect it to our live one. And understand that the actual board is connected to the breadboards. There's actually 2 breadboards, both going to the power to display. So that's ultimately your purpose. So for each one of these A, B, C, D, and so on for our LED display, remember each one has its own current flow going in, and then the logical part goes to the chip, the Arduino chip, that will regulate this logically. Remember, just as a reminder, we have to calculate our power, so that's the power will equal whatever the number is, 1.2, and times our current, which is denoted as capital I, in terms of it going forward. That's lowercase f. So ultimately, we should remember that power equals current flow forward times voltage in, which is the voltage going in, minus the voltage going forward, minus 1.2. Now, individually, you can understand that the current is denoted by 1.2 divided by the second resistance, or R2. Okay. Also remember that in an IC, we have a pin for going in and a pin for going out. The out's going to be denoted as R2, which is resistance 2, which is the current limited output. And the GPI pin will indicate the pin going in, which will indicate resistance 1. And then, of course, after that, we have a switch. We have a Q1, and then it goes to ground. Now, remember, all the time, at the end is always ground, because that will end the circuit itself. Also remember that anode refers to positive and cathode refers to minus. Okay. Remember, it's in terms of red, green, blue. And basically, your most basic thing is to understand that GPIO pin, which is general purpose input output pin going in, goes to a resistor to limit the current flow in terms of its voltage, and then the current is directed by a diode, and its power powers up the LED, and after that, whatever's left over goes to ground, as not to fry the circuit. All right, so I'd like to thank you for taking the time to watch this video, as you could be watching any other electronics video, but you're watching my video, so I do appreciate that, as this did provide value for you to learn about basic electronics and its application to Raspberry Pi and Arduino. What I'd like you to do is please click like on the video. That way it'll be pushed to the algorithm and more people will be able to view it and enjoy it. If you haven't already, please click the subscribe. That way you'll have access to all the content on this channel, as I do have a variety of topics on this channel. In addition to that, if you haven't already, please click the bell button. That way you'll be notified of all my future videos. That way you'll be notified when any new videos come out, and that way you won't miss any of my new videos as they do come out. So I'd like to wish you a great day wherever you are in the world. Take care, and I'll talk to you.